To further expand on the idea of using a two-sensor solution to produce a quasi-analytic signal and how that compares to actual measurement of the three independent gradients, we have an additional paper available on our website called Empirical Transverse Gradiometer Data Processing. I want to bring your attention to the results of the analysis that compares the two types of processing. As we referred to earlier in the TVG, the 882 transverse gradiometer case, we have two magnetometers measuring the transverse gradient, and then we also measure along the track as a time series and compute the vertical. This graphic compares the total field, the analytic signal using multiple sensor arrays, and the quasi-analytic signal response at different field angles. And so here we have the field being at vertical, so this would be at like the North Pole. Here we would have it at a 50-degree angle, such as San Francisco. Here we would have it as a 20-degree angle, such as in Ecuador. And here we would have it as a zero field angle, such as the tip of India or Liberia. Here we have the field at a 75-degree angle, such as New Jersey, but with the angle, the declination of the field, the relative to geographic north, turned by 20 degrees. So what we see here is that the North Pole, we're going to have a bullseye effect from the total field. The quasi-analytics, the analytic signal also presents a bullseye type phenomenon. You'll notice that it's higher frequency and has a bit of a low cut in the actual response. And we see from the quasi-analytic signal using two sensors, not three or four, we get a very similar response. In fact, when we were, if we were to be characterizing the anomalies and presenting a map, we would essentially see the same response from the target. Similarly, at an inclination angle of 50 degrees, we see the sombrero type response that is typical of an angle of approximately 45 to 50 degrees. We see that the analytic signal is still rather round, and so is the quasi-analytic signal. The point being here that as the field changes from an angle of 50 degrees to 20 degrees to 0 degrees, the actual response of the magnetometer to the magnetic field is very similar whether we use a complete definition of the analytic field or do a quasi-analytic signal processing. We see that as the field is tilted due to a declination of the Earth's magnetic field, we do get a slightly distorted effect in the quasi-analytic signal. However, we still would pick this as a target, and it would still be presented on the map as a clear target for our analysis. Also presented in this paper is a case study where we did some analysis over a pipeline using standard analytic signal and quasi-analytic signal processing paths. And we see in the total field, we can easily see the plus and minus variations from the ends of the pipes. In the analytic signal, we see a clear positive anomaly, all positive anomaly. And with the quasi-analytic signal, we see almost precisely the same response. So again, this case study shows that for 99% of the cases, the quasi-analytic signal with two sensors will produce the same data as 3 or 4 sensor arrays.